Ever wondered what actually happens inside a neural network when the loss goes down? Today we're breaking down activation functions, the nonlinear switch that makes deep learning work at all. Every neuron computes a weighted sum, then passes it through an activation function before sending the result forward. Without that function, stacking 100 layers still collapses to a single linear equation, no matter how deep the network goes. You can add as many layers as you want, but without nonlinearity, they all cancel into one. Activation functions break that collapse and let the network learn curves, boundaries, and complex patterns no straight line could capture. Sigmoid squashes any input to a value between 0 and 1, perfect for binary output layers where you need a probability. But in hidden layers it saturates at both ends, gradients vanish, and weights stop updating. This is the vanishing gradient problem, and it's why deep sigmoid networks were nearly untrainable before modern techniques arrived. Tanh fixes the zero-centering problem, outputs -1 to +1, and gives stronger gradients. Strictly better than sigmoid for hidden layers, though it still suffers from vanishing gradients at the extremes. ReLU changed everything. Max of 0 and z. No vanishing gradient for positive inputs, computationally cheap, and roughly half the neurons output 0 on any given pass. That sparsity turned out to be a feature, not a bug, and ReLU became the default for hidden layers in almost every deep network built since 2012. But ReLU has one failure mode, dying neurons. A large negative gradient update can push a neuron permanently below 0. Gradient becomes 0 forever, and that neuron contributes nothing to learning ever again. Leaky ReLU fixes this by allowing a small slope below 0, so the gradient never fully disappears. ELU uses a smooth exponential curve instead of a hard kink, often converging better at the cost of slightly more compute. Both exist for one reason, to stop neurons from dying. Softmax belongs in a different category entirely. It takes a vector of raw scores, called logits, and converts them to probabilities that sum to exactly 1. Watch the example. Scores of 2.0, 1.0, and 0.1 become 65.9%, 24.2%, and 9.9%. The highest score dominates, and the total is always 1. Use softmax only at the output layer for multi-class classification, never in hidden layers. Choosing the right activation comes down to a few clear rules. Hidden layers. Start with ReLU, switch to Leaky ReLU if neurons are dying, try ELU for smoother convergence. Binary classification output, Sigmoid. Multi-class output, Softmax. Regression output, linear, no activation at all. And in modern transformers and large language models, DLU and Swish have largely replaced ReLU. Smoother curves, better empirical results at scale. Sigmoid for binary output. ReLU for hidden layers. Softmax to turn logits into probabilities. Get those 3 right, and you have the foundation of every neural network running today. Thanks for watching. If this helped, like, comment, and subscribe.